So, good morning, everybody. Feels good to be back here in this beautiful air and good air and clean environment. That was quite different the last days. And it was interesting to see you last week from Singapore. How was that? Was that weird, or how was it? Matthias Standfest was speaking here. I was speaking from there. How would you say how much get through from Singapore? 90%, 80%, 70%, 60%?
90% or more. It was pretty clear.
Could you, the sound quality was clear, but you didn't have the three-dimensional experience of somebody wandering around. If you had a question, do you think it was more difficult to ask it to Singapore or if I'm here? Don't ask questions at all. But these are the important questions we have, because that depends how far we can push this technology. Good. Last question before we start. Did all of you receive from the Rektorat this email about evaluating the courses? Yes? And may I ask you to do the evaluation this week, because I think it closes at the 28th. And we would really appreciate your feedback. It would be great. Good, so let's start. Today is the ninth lecture, and it's still on information architecture of cities, and we are getting to the base of it, so to the bottom, you could say. The second last lecture next week, we have the last one, December 1st, and then also on December 1st, we have the combined critique with the other courses, so you will see many results from the other courses. Today, our topic is the territory as a system. So we moved from the house to the city, now to the territory as a system. And in that system of the territory, mobility as an important topic. Mobility and transportation. We will start with a look at the exercise 2 results and the course evaluation. I already told you about that. I want to select, or we have selected 2 exercises from the exercise 2 because they are very good. Then a few words on territory as a system, then agent-based modeling, the Zurich model, the Singapore model, and in the end, outlook to exercise 3 and the last lecture. Let's switch to the 2 exercises. So we selected 2. One is from Basile Diem. Are you here? Yeah? Okay. So we found that quite nice. And the other one is from Marc Lallemand. He excused him. You're here. You made it.
Yeah.
Oh, good. Didn't you write that you couldn't make it?
No, that wasn't new.
Oh, that was new? Okay, good. So, no, we then had selected the third one. But that's okay. So we take yours. That's very good. Very good. So you remember the exercise 2, of course, and that was the most livable city for you personally. And you gave the examples for it. So you gave the name, of course, the number of inhabitants, the square area, the area of the city, how many inhabitants of the city has per square kilometer, the density, and then the extension of the height. And later you also gave the mean temperature and the Gini coefficient. So your choice was, why don't you say a few words to that? You get the microphone? Yeah?
I chose these cities because that's the 3 cities that I lived in, Lausanne, Munich and Zurich, and the rest are cities that I just visited, and it can make a little difference because when you visited a city it's not the same as living in a city. But it's the cities that for me are the most livable that I saw, and because of the 5 factors that I choose, the water presence. In the case of Lausanne, it's the lake, and in the case of the other cities, it's the river. And I think it's something very important because it brings, for the livability of the city and the activities, it brings a lot. And then that was the cleanliness of the streets, the public transportation. In Lausanne we have the metro, which is something very easy to use, much more than the bus or the train, I think. And then the green zone. I choose the Central Park because it's a good example. But in Munich there are the Englische Garten, which is a big green space in the middle of the city. And the last one is the coast of the city, which take for the flat or for the feed.
Right.
Food.
Right. And then also you talk about the Gini coefficient, and that's quite interesting. You didn't find the Gini coefficient of the city of Lausanne, so you took the one of the whole country, right?
Yeah.
Of Switzerland. And it is 0.285 and very high GDP. And it happens Sweden is also an even lower Gini coefficient, 0.24, also quite high GDP. And Munich is Gini coefficient also below 0.3, as we said last time, is an important threshold, and also quite a high GDP. Can you go on? So Prague, Zurich, again the same story, relatively low Gini coefficient, very, very high GDP, and Prague, the same story. So it seems a coincidence, or do you think it's a coincidence, or is it, you think it really has an impact?
It's tough to say, but I think it has an impact because it shows that the city are in a good shape and a good form, economical reform, saying.
Right.
And I think when it's the case, then you are comfortable in these cities.
Right.
Then I think it's not just a coincidence.
And the inequality is not too large, which normally leads to all kinds of secondary effects, such as insecurity, crime, safety problems, and so on.
Yeah.
So, but you never know what is the cause and what is the effect. And therefore, we shouldn't be trapped into thinking just let's reduce the Gini coefficient and the city will rise in livability. Because recently in the newspaper you might have read it that this equality and inequality discussion is now being attacked from different sides, that people say it's not enough just to provide equality because there will never be total equality. It cannot be because then all the progress is not progressing, and therefore the Gini coefficient is to be observed both as a cause and as an effect. So very good, thank you for that. And go back maybe to the first page, Dong-Yon, where he listed the most important factors. One up. Yes. So water, the cleanliness in the streets, good transportation network, green zone, and price of living. So these were your four major topics. Thank you very much. Then we go to the other example from Marc Lallemand, and he has selected other cities. He has interesting, you say the same thing as he just mentioned, that you have to live in the city to decide on how livable it is. It makes sense. I never thought of that. Because many people who do these rankings, they don't live in those cities and they do the rankings anyway. Good, and keep going up. Next page. So you made actually a table. You made yourself different categories, and then you put everything in the table, and you had one clear winner. Could you say, not clear winner, but relative winner? So maybe you could also say which are the most important criteria for you, because not everybody
Sure.
might be able to read it.
Similar to the other example, I also focused on the cities in which I had lived, and then I just picked criterias that were most related personally to me and my life and what I experience in a city. So public transportation is important, the possibility of using a bike to commute, the relationship of income to cost, cultural offering, openness, climate, and territorial connectivity. I think they're all relatively clear. Openness, specifically as a foreigner living in other cities, you normally want to live in an environment where you feel welcomed. So that's an important factor to consider. And territorial connectivity, I sort of relate that to here in Zurich. You can visit other cities through the train, through flying as well, but it's really well connected, and I think that's important so that the city has influence and is not hermetic and distanced away from other cities. I think it's good to have influence from neighboring cities. So these were the criterias, and from the 7 cities in which I lived, Zurich came out on top, just above Berlin.
Very good. And maybe we can move to the next page and then to the last page. First to the next page.
So this was, yeah, if you go back one page, if it's possible, in the end, one thing I was able, by looking at some of the statistics, I found that the Gini coefficient did match relatively well with the cities that I also thought were livable. And I think there's also some relationship to how many people live in that city. If you look at the population, cities that are really huge might become a bit unmanageable, and cities that are really small might not have everything you're looking for in your life in a city. So I was able to say that cities between 1.5 million to 3 million are probably cities that tend to do fairly well in terms of offering everything you would like to find without becoming unmanageable in terms of size.
Right. And this recognition is very important because it coincides with many scientific findings that we read in paper. So you made this conclusion from a few data sets, but if you expand your data set, it is becoming, it gets more evidence. So cities between 1.5, 2 and 5 million are manageable, are in a good size for a larger city. Anything beyond is difficult, anything below doesn't have the intensity that you sometimes want from cities to have. Also, you might have seen, if you look at the Gini coefficients of the city itself, if you get the Gini coefficient of the city versus the country, normally the Gini coefficient of the cities is higher than for the overall country, because in the city you have more competition, more inequality, not massively more, but more inequality than the rest of the country, because people tend to be drawn to the city also because of competition. So you have a natural peak of Gini coefficients in the cities, just for you to understand when you have differences between city and country, like in Switzerland. Okay, and your results I find, your conclusions I find quite interesting. Obviously here the mean monthly temperatures don't seem to make such a big difference to the livability of the city, although they are quite different. Zurich, interesting, is just in the middle, so it's an average. Berlin as well. Go to the conclusions, the last page. Okay, very, very thoughtful conclusions. What is your most important one? What do you draw from that?
I think what I had said before about the size and that the Gini coefficient I thought matched relatively well. I didn't mention it before, but the existing city livability standards, you sort of have to look at them because I think there's different focuses. Monocle versus
Mercer.
the Mercer,
Yeah.
they seem to have a little bit different focus because the cities that I was looking at stacked up a bit differently. And then, yeah, I mean, I think those were the strongest elements I was able to pull out of the work.
Right. Okay, great. So, Donghyun, now you can switch back to the other ones. So thank you for these exercises. And now, I think it became clear to you what you did here was an analysis. How can you now turn it around? Is it possible to turn the analysis around? Because you cannot just say, okay, I make a city, I define the Gini coefficient, I define the livability, and it will be the best city in the world. It doesn't work, right? This is just the analysis of existing cities. And you try to understand what are the factors that makes them livable or better than other cities. The difficult part in design is, of course, always to turn it around and to learn from these analyses and turn them into synthesis. In politics, I was told there's nothing worse than to have a very good solution for a problem that the people you try to convince don't see for a problem, don't see as a problem. So you in architecture, it could be the same case. You say, I want to study architecture, I want to build buildings. So what do I do with cities? The fact that you are taking this course is that you are somehow interested in. But I think it is still difficult for all of us to see how we can turn these analysis results into design. Fortunately, and this is not coincidence, but it is a little bit of coincidence, the topic of today, the main topic of today, transportation, mobility, is in 17 of the 23 exercises that you handed in, one of the top topics. And in 4 of the 23, it's the number 1 topic. So transportation somehow must have to do something, in your view, with the livability of a city. And I didn't know that this was the case when we designed the course at the beginning, but it so happens that today the main topic is mobility and transportation. And this is where we are in the course, as we show every week. And today we really want to focus on this one here, mobility and transportation. Mobility and transportation is part of the same story of the system. I bring the same definition again we had last time and the time before, but the system defining a set of objects acting together as part of a whole. In this lecture, the object is the transportation. You cannot separate it from the rest. And you cannot separate the transportation planning from the urban planning, from the urban design. Let's have a look how professional transportation planners and the forefront of research in transportation planning and mobility look at this problem. Here, you remember that maybe from the energy lecture on energy. These are all parts of the system. The production, but also the transportation. These people here have to get to their workplace somehow. Normally in some cities totally with private cars, in other cities with public transportation. And then it continues. The system to make the fuel for these cars is produced in another part of the city or another part of the country, and also to fuel the lights in the evening and the running of all the mobility, the vertical mobility in the high-rises is produced somewhere else. So you see it's stretching beyond the limits of the building or the limit of the quarter or the limit of the city. Very far away. The person who is dealing with that on a very high professional level here at the ETH is this gentleman. Somebody know him? Do you know him? No? Kai Axhausen, very famous man. in the Department of Civil Engineering, and he's focusing on this problem of mobility and transportation planning. This here is our example that we have from before. You know the city, of course, the Singapore, and we have different lessons learned from different cities that I want to compare. 3 cities. One is Jakarta, one is Singapore, and one is Zurich. And we have some quotes from people in these 3 cities that are quite fitting to these 3 cities, or that are quite characteristic for these 3 cities. So in Jakarta, I experienced that myself, and I wanted to give a lecture in Jakarta to here. I didn't make it to the lecture because I was stuck in traffic. And the quote there, you cannot see it from the back. It says, for a typical person traveling in such a traffic jam, I work on my BlackBerry in the traffic jam, I want my own car plus driver. So the car turns into the office because it's not possible to get to the office in time. So this is a common problem in huge metropolis, and this cannot be the solution for a city or for the normal people who work there. In Singapore, it's a different story. There we have a big plan of MRT, this mass rapid transit system, to extend the public transportation. And there somebody who's living in Singapore says, typical quote, I use the mass rapid transit system and the taxi. I don't want a new car, and I prefer to go on holiday instead. It is too hot for cycling and it is dangerous. So in Singapore, can you confirm that, or do you have a different idea?
I guess the reason the person doesn't want a new car is the cost of the car, because it's a system where it's like they have the certificates of entitlement, and it's many times more expensive than the car itself. So the price of a car would be much more expensive than in Switzerland, I guess.
Right. So you take a common car here, but before you can register the car, you have to get this COE, this entitlement, and you have to buy this license plate if you want. And this license plate is up to demand. So the total number of cars in the city is limited. It's a range limited. It's about 820,000 cars. And so if so many people give back their licenses, then the price of a new license is going down. If many people want a new license, it's going up. So the license price, correct me if I'm wrong, but it can range between $30,000 and more than $100,000.
I think so.
Yes, it is. So that's just the license plate. Then comes the car, and on top of the car comes another 100% tax. And that makes the total cost of the car. So you cannot understand here, where you also pay taxes on cars, of course, but you don't pay these amounts for license plates and so on. But this is saving or making almost no traffic jams or very little traffic jams in the city. So this is a different way to approach transportation. And then in Zurich, finally, here people are relaxed, car sharing and multimodal transportation, increase in connectivity. Today 50% of streets have dedicated bicycle paths, and that is not the best in Europe, I would say, because if you go to Copenhagen and other cities, it's much better. And here a typical quote from a person is, I cycle and I use public transport, it is fast, cheap and healthy. So totally different attitude. Same way or same task to get from your housing to work, but very different cities, very different attitudes, very different results. To make this somehow compatible, we use agent-based simulation. Agent simulation is meant to represent the behavior of an urban population using a program. In this case, it's the so-called MatSim program. The goal is to improve the transportation and mobility situation in emerging cities, such as Jakarta and the really large ones, by developing scenarios. So we try to show how it could be and then plan accordingly. Finally, the integration of simulation and urban planning is our goal. And this is, I think, what you as architects or urban planners need to get more and more familiar with. The same story, analysis is not enough. What do we do about it? And here we need to create scenarios in the future and then simulate them and see if we can get from here to there. The scenarios of the future and this connection between simulation and urban planning are the biggest steps or the biggest departure from the past. In the past, all these different disciplines were in different departments. Now, with the Future Cities Laboratory and also increasingly at ETH, maybe also at your university, they come closer together. And we start to be able to talk to each other from these two sides. The background to that, or one of the possible approaches, is the so-called activity-based modeling. And here you have the very rough description of a town. You see only the streets, the street network. You see, of course, the public transportation, the big MRT, the mass rapid transit system, the green one. Then you have this other second big line here. You have an intersection. You have a bus line going this way. And you have houses there. You have probably a school here. You have some industry here, and so on. And so these are all, and they have a recreational park, maybe, and somewhere some leisure places as well. So these are all activities that a typical person does during the day. But how do we express that? How do we bring together those activities with the streets, and not only with the streets, but with the buildings, and how do we bring that together with the urban planning? So this is the problem. And you must always imagine that people who develop these programs or these representations or these models, they have a completely different understanding of architecture than you have, or they may have a different understanding of architecture than you have. For them, maybe architecture is really a this or this. It's a symbolic representation of an entity within a large system. For them, maybe the most important system is the transportation, the stocks and flows of transportation. And how that influences the rest is not their topic at the moment. Their topic at the moment is to really make an optimal connection between the different activities of a person during the day. This agent-based modeling helps us to do that. Here we see how this works. We have a typical person, age 11 is her or his home, and you can see how this person is traveling to a certain point. This will go on over and over and over again. But important is how this person and this activity is represented to the computer so that we can make a simulation out of this. You can see it here. It's a simple program, a simple representation. A person has an ID, has a sex, female, age, has a license. Does she have a license for driving a car? Yes. Does she have a car available always, or is it car sharing? She has it always available. Is she employed or not employed? Yes. And so it goes on, the specification of that person. And then also that person travels from her home, which is situated here, which has exact coordinates in the city, to that place, and finally to her work, which is down here. Then on the way home, she might go shopping or stopping or do exercises or whatever, and then continue back home. So that's the typical activity life cycle of a day of a person, in this case in Singapore. The idea now was to make that for every single person in Singapore, for 5.3 million people, which is not easy. How do you get their life behavior during a day? Is it even legal to get that? Is it useful to get that? We agreed it's useful because only then you know where people go, how far distances they travel, if they like it or not. Maybe they choose another workplace because of too long travel and so on. If we blow this up now to the entire city, you can see what happens. A morning in Singapore with Madsen. Now we extrapolate this number not from one person but to many, many hundred persons, actually 5.3 million, and we take a small sample of those as a well, as a sample. And we see the entire island of Singapore, which you know by now quite well, and simulate that behavior over time. Mind you, it's a simulation. This is not a recording of data, but we use the recorded data to verify the simulation. And up there you see the time running at the top. This group of Professor Kai Axhausen does a wonderful job to do these things, to simulate these things, to visualize these things together with us then in the simulation platform. Here, for example, is the airport, and you can see 10 o'clock in the morning. Public transport to the airport is quite high. You can see where they come, where they go. But if you observe now in the morning, starting again before 6 o'clock, most of the transportation is this pink or purple. This is all public transportation. And as it gets later, more and more private cars get on the street. You can see how it gets greener. This is the private cars. So this is part of the stocks and flows of transportation in the city, and every single car, every single person is modeled the way I showed you before. How do you get this data? This links us a little bit now to architecture. You can get data directly from surveys. Surveys you probably have filled out yourself. When you get up in the morning, how long does it take you to get to your work or whatever? This is the so-called HITS survey, which happens every few years in Singapore and in other places as well, where a selected number, a small number of people, describes exactly how they behave during the day. This is important because the schedule shows you how you can should use your buildings, your streets, and so on. And here you can see that most of activity, all activities and consistent public transportation activities are between the peaks, different peaks, between 8 and 9 when they go to work, and then we have a corresponding and important corresponding counterpart to that, which comes from big data. If you remember last week, the lecture, Big Data, how and why it is important, this now is a little part of big data because these are all the check-in, check-out activities of the people with the smart cards for the public transportation. So when you enter a bus or enter the MRT, you hold your card there, checks you in. If you leave it, checks you out. And you can see quite a corresponding picture here, at least in this part, between that and the survey. The survey is smaller sample, but seems to be quite right. This year's big data, a huge sample, but has the same shape. This is important because it tells us our survey and the big data are giving us the same picture. From that then, you can detect the number of workplaces. And you can see how people get to their workplaces. This is a bit more complicated, but this group could do that. And here you could see the private and other transport is the dark blue, and the light blue is public transportation. So for each workplace, for example here at the airport, you can see it's 50-50. They come by car or they come by public transportation. Whereas in other places, you have where you have a large blue part, here you can't even see it, downtown, there's no parking spaces, not enough parking spaces, so many people come with public transportation. Whereas in the outskirts, back here in the west, where the Nanyang Technological University is located, many people come actually with their own cars. Then you can also show how this distributes in accordance to the master plan of Singapore. So here, the first time is a relation between the planning and the actual distribution of the transportation modes. And you can see the airport here, very, very big cluster. Then you can see downtown here, very, very big cluster. All the transportation modes are represented there. Of course, because in cold climates, in hot climates, you want to minimize the walking time. And that is one of the reasons why you see all these many, many dots. You know what the dots are? These are all your bus stops in Singapore. Bus stops and and access points to subway. And then from this you can detect where the workplace locations are. There's no direct data on this, but we can detect this from the travel behavior of the people at a certain time where most likely their working place is. This is an interesting observation because in other countries like Switzerland, you get this data directly. Here in other countries where you don't give the actual workplace location, there you have to get it indirectly. And again, this is another view. We're looking from the west now to Singapore, so you see the industrial parts back there. And here you see the downtown area, and all the way up there is the airport. And in the middle you have the big reservoirs, so you can clearly see from this travel behavior you can link back to the most likely places of work in Singapore. An updated version of this now, more sophisticated. Every year the simulations get more sophisticated. By now we can zoom into even parts of the city, make it more and more precise. The number of cars and transportation modes is increasing, and we can zoom into details. We can start to imagine, would it be making sense to have a higher ERP? You know what that is? ERP? Electronic road pricing system. That means if you enter certain parts of the city, you get charged in addition. It's deducted from your account. And we can see how the ERP zones are relating to traffic jams or not. That would give the traffic planners an indication if they would have to increase the amount of money you have to pay if you enter these high frequency routes or not. And if they do that, where the transportation would go to. Maybe it would then create a traffic jam in another place of the city. But if you have such a working model with all these hundreds of thousands or millions of people represented, then you can make very informed decisions what the effect of certain changes in the ERP, the road network, closing roads or whatever would be. Yes?
Sorry, what are the flashing dots now in this simulation?
These ones here?
Yeah.
These are destination and where people are going and where they're coming from.
But the size or something doesn't matter?
It matters the number of people. So if you have a bigger size, it's for example an apartment building. In the morning, people are leaving.
Entering
from
in
there.
and out.
Yes, yes. So underneath is all the same data. It's just different representation. It's most of these blinking things is the destination and the source representation. Of course, it's not real time. These are humongous amounts of data that have to be processed. So these are recorded step frame by frame and then put together. In a few years, that will be real time on your computer. But it gives you a very good idea. Now, look, this for the stocks and flows of transportation of people in a city, I think. Yeah? We never had this view before, and that should start to teach us. This is a visual language we have to learn and draw conclusions from that to our urban design. So if you want to generate the same traffic problems as before, we have to just keep designing the cities the same way as before. If you want to stop that and make a better distribution of transportation mobility in the city, we have to change the design. That's the most important lesson I think I want you to get today. You can take it now down from this territorial system. In Singapore, you would say the whole territory is the island. But in a city like Zurich or Paris, the territorial system surrounding the city would be much larger. In Singapore, you also can go to Malaysia or to Indonesia on certain parts, but it's a much smaller connection than you have if you're not on an island. So the territorial connection of Singapore is mainly through the sky, through the airport, and through 2 or 3 connections on land to Malaysia. But if you look into the city now itself, how the individual modes of transportation can be better represented. And here, again, we have this comparison between the agent-based transportation simulation that you saw before, and now the new topic, of big data or data-driven transport planning. Here we can start to directly deduct from how it is now, predict a little bit into the future. And not only on mobility with cars and MRTs, but now we want to look at the pedestrian part of it. This is interesting. The dynamics of operation, how much boarding and alighting, getting in and out of a bus, you need to know what determines the variability of travel time between stops. There are many, many different reasons for that. And then you have to adapt your MATSIM model, this simulation program I mentioned before, to these different inputs. You can get directly the data from the check-in, check-out as input for the MATSIM data now. And here you have an example when you put these things together. Remember this here, but these funny signs here, these are bus routes through the city, and now they're trying to optimize these bus routes. The point is that normally when the buses start in the morning, within 10-15 minutes they end at their destinations because they have no dedicated stop times. They just stop when there are people waving. So in the morning there's not much traffic, they just rush through. When there's traffic jams, they need, instead of 10 minutes, maybe half an hour or even 1 hour. How to improve this? So here is the idea. We click.
Let us look at a typical test case where we have a very long bus line that covers more than 90 stops along its route. This bus line shows that extensive bus bunching occurs. Especially in the second part of the service route, reliability becomes more affected by traffic conditions and the boarding and alighting of passengers along the way. As a possible solution to the problem, we can split the line in two at a position which minimizes the need for extra transfers and then evaluate the service performance. As expected, the line split has removed most of the bus bunching cases, and commuters benefit from shorter waiting times and less crowded buses. We can now evaluate how passengers will be affected by comparing travel times and the number of transfers made before and after the change. We can also see that passengers could switch from using this line, or how the improved reliability might attract passengers from other public transport services. In fact, the system can simulate even more complicated scenarios, such as predicting ridership of new lines or assessing the impact of a city-wide network redesign.
So that was also produced by the group around Professor Axhausen. And then going even further down, not to bus drives, but to walking, you can make similar simulation in that you take the individual person working as individual agents and connect it to walkability. And here you can see we're entering very closely into the field of architecture and planning. And maybe just one other short clip, how to improve walkability in the city.
Walking along a major road without any amenities or across an overhead.
So this is Singapore as well, as you might be able to tell by now.
Across a vibrant pedestrian area or through a park. To find out what people value when walking in Singapore's dense urban environment, we teamed up with Singapore's Urban Redevelopment Authority to measure the walkability of the city centre.
This is our exhibition.
We organized the research project in
This is the Value Lab, of course, from where I spoke.
Measuring behavior and analysis and development. In the first phase of the project, research assistants set out to assess the pedestrian network in Singapore's downtown area. Link by link, they measured physical characteristics such as the width of the sidewalk, shelter from rain, noise level, and the presence of shade. In addition, they mapped urban design qualities to account for the comfort level and how interesting it is to walk down a particular street. In the next phase, we mapped the routes which pedestrians actually take. To this end, we developed an app and tracked about 1,000 walks taken by pedestrians. As they arrived at their destination, we asked the pedestrians about their walking experience and invited them to participate in a follow-up survey. We then use this data to identify what influences where people walk and how it affects the experience. For example, the quality of the walk might decrease while walking along a busy road or waiting at traffic lights. Interesting shops, restaurants, and bars along the route.
Okay, it tells me to stop, but you can imagine how it works. So it continues like this, and now you see, I hope, the direct connection between this personal mobility and transportation to the next level, the car, the MRTs and so on, and then to the territorial. In the next and last lecture, we will focus on the influence on of the territory on the city and vice versa. It would be great to get your exercises by then, next time, and fill out the evaluation. And I look forward to see you next Monday. Thank you very much. Yes?
Would it be possible to just read through the assignment once more that were assigned for next week?
Yes. Okay.
I was just had some curiosity about the first part, if it's possible.
This is the outlook for next week. This one here?
Yeah. So just the first point, identify and describe 2 attractive non-urban, non-city settlements.
Yes.
Which nevertheless show characteristics of an urban settlement.
Right. You cannot imagine what that could be.
I'm imagining what it could be, but
yeah.
I'm not sure. Maybe if there would be an example.
I see. Yeah, that makes sense, because you said you have to have been there in order to imagine. If you haven't been in places like this, then you would have to not make one up, but to imagine one. As a matter of fact, Switzerland is in many parts kind of non-urban, but still urban, huge country, because it doesn't have all the characteristics of an urban center, doesn't have high-rises and so on, but even small places in the Alps have very urban structures and very urban qualities, but they're not really big cities. So that would be to help you get an idea. But if somebody knows about, in Asia, for example, northern India, or the island of Java that I mentioned before, and other places where informal settlements emerge very quickly. They are not really cities, but they have many of these stocks and flows that we talked about and are developing into cities. So if you can think of those, that would be to the first one. And to make them attractive, to describe them as attractive, is of course a bit difficult. But many of you, I think, know from the past, just think about it, where you used to live, or places you know, they don't have to be big, they can be small, but that have urban characters, urban stocks and flows, but are not really big cities. And this is really to think of the future, because in the future maybe we don't need big cities anymore. I mean huge cities. Maybe we need this alternative if you can find attractive ways to use those. The last point is important in this. Describe 2 approaches how buildings in urban sprawl areas could be transformed from a perceived liability into an asset. Because it's a fact that many cities have huge sprawl areas around it. You cannot just tear them down, destroy them. Maybe you can reuse them for something else, or as they are. So that is really kind of thinking ahead exercise. Yes?
Yeah, I was just wondering, the example you gave was on Singapore, which is, of course, a very regulated city.
Yes.
So how would you implement this approach of big data, and how can you trust the data you gather in a sort of informal city, which is, of course, more a future city than Singapore, and maybe Singapore is more the city of the future, but actual future cities are the cities which are expanding now and growing. These need answering with these big data questions, I guess, more than Singapore, maybe.
Yes,
So
but therefore, Singapore was really just an example. Think of a counter-example to Singapore. I mean, Singapore is really a peak example of organization and data availability and everything. Think of the counter-example, because the majority of people in the world live on the other side of this.
Yeah.
But from the advantages of organization, of also implementation and managing things, you can learn from these examples and maybe transport some of them to the others. For example, the urban sprawl areas in the United States, or here, or in other places, could be turned into energy-producing areas. So suddenly it would be a completely different attitude towards them. Maybe suddenly they are most attractive living areas again, by just changing the energy supply, changing the cost structure. So changing maybe also the planning of these urban sprawl areas to allow for more functions, have mixed use suddenly. And so that could really generate a picture like we have in Switzerland, which I wanted to show you like this. You know, this is Switzerland. This is actually Zurich, and you see it's a small, very concentrated core in Zurich, but around it you can expand this for many, many, many miles, and it's really like a network of smaller cities. It's not a huge city. So this Switzerland is actually already an example for totally cosmopolitan world city feeling, infrastructure, but in a very small body, if you want. And it has many, many connections to the outside. So try to think upside down or inverse.
That's for the exercise, it's
Yeah.
manageable, but I mean, if you really want to use this big data, an informal settlement doesn't have any advantages by producing big data, I guess, because they're sort of informal and therefore not regulated.
Okay, allow me to disagree. Maybe we have to have another. That's a good point. I will bring that next lecture, because especially in these informal settlements, as Matthias Standfest said last time, there are more smartphones than toilets, for example. And this is the case. They produce as many or more big data than we do. And
Just a
there
different
you go. So sorry. So this is not the problem, but the problem is to use this big data for design. And there they produce a very interesting option that we don't have in these built-up cities, because these big data they are producing might lead to the possibility that rather than moving people around, at this point, when everything is still informal, we could use buildings and functions around. So it might very well lead more directly to design implications than here.
Yeah.
And the applications they actually wrote for South Africa with Brillenburg and Klumpner shows exactly that interaction between buildings and people and people's wishes and movements and maybe big data. So really, this is an outlook. Don't feel limited in this way. Just try to react to these three questions and just think ahead how it could be. And 20 years, 50 years ago, everybody said, nobody wants to live in cities. Now everybody has to live in cities. Think of time, These things change over time. But you are students of architecture. You have to think independent and beyond current fashions. But from all the things you heard and learned in the semester, make your future city. Okay? Be experimental. Very good. So sorry again to keep you longer. Have a very nice week.